Giant ants attacking cities, massive spiders trapping people in their webs. These are the thrilling scenes of classic B-movies. But in real life, insects could never grow to such monstrous proportions. Why? Their biology simply won't allow it. In the animal kingdom, size is determined by a complex interplay of hormones and environmental factors. Insects, with their rigid exoskeletons and unique respiratory systems, face particular limitations on how large they can become. Let's delve into the fascinating world of insect hormones to understand why giant bugs remain a thing of science fiction. Imagine a car's accelerator. That's what hormones like insulin do for growth in insects and other animals. These hormones speed up cell division and nutrient absorption, making the animal grow faster. But just like a car has a top speed, there's a limit to how fast an insect can grow. This limit exists because insect cells need time to copy their DNA and divide properly. If growth hormones push too hard, it's like pressing the accelerator to the floor all the time. The engine will overheat and break down. Similarly, uncontrolled growth in insects would lead to developmental problems and ultimately death. Now, imagine a timer that determines how long a car can run. This is where two other hormones come into play, controlling the duration of growth and the timing of maturation. These hormones, called ecdysone and juvenile hormone, work together to ensure that insects develop in stages, molting their exoskeletons at specific times. As an insect grows, ecdysone levels rise, triggering molting. Juvenile hormone keeps the insect in its larval stage, allowing it to continue growing. Eventually, juvenile hormone levels drop, signaling the final molt into adulthood. At this point, the growth timer stops and the insect reaches its maximum size. Section 4. Gravity's grip on size. Imagine trying to lift a car with your bare hands. It's impossible because gravity pulls it down with enormous force. Larger animals, including giant hypothetical insects, would face a similar problem. Their massive bodies would be extremely heavy, making movement difficult and energy-consuming. Insects rely on a system of tubes called tracheae to breathe. These trachea are efficient for small bodies, but would struggle to supply enough oxygen to the enormous bulk of a giant insect. Gravity, combined with the limitations of their respiratory systems and exoskeletons, effectively prevents insects from achieving the gargantuan sizes seen in movies. Section 5. Why insects will never rule the Earth. So while giant insect monsters make for entertaining fiction, they are scientifically impossible. The intricate interplay of hormones, the constraints of their exoskeletons, and the relentless force of gravity all conspire to keep insects relatively small. This is not to say that insects are insignificant. On the contrary, their small size is one of the keys to their success. It allows them to inhabit a wide range of ecological niches, exploit diverse food sources, and reproduce rapidly. In the grand scheme of life on Earth, insects have carved out their own unique and essential place, proving that size isn't everything.